Hi everyone, welcome to today's class. And today we are going to cover linked list. As already displayed on the board, you might have get what other topics we are going to cover. So, starting with linked list, the topics we are going to cover today are a single linked list only. The doubly and the circular will be covering in later part of the playlist. Talking about the linked list, what linked list basically means is uh, why there is a need of a separate data structure in like linear data structure that is linked list, because instead of going with traditional approach of array, linked list is also like a straight connecting nodes one after other. like let's say we do have a different nodes that are connected one after other, and in a single linked list only the current node is having access to go to the next node, but we cannot go back from next node to the previous node, or to the from the last node to the first node. So if there is a connection between the last node and the first node, then that will be called as a circular list. Today we are not going to cover that. And if there is a linkage from current node to previous node, then that would be simply called as doubly linked list, because you have a path to go forward and go backward as well. So in today's lecture we will be discussing this part only, where we are having a movement access from the current node to next node, right? So why there is specifically need of having a linked list instead of going with traditional array, right? So the very first thing is adding or updating nodes in between, or deleting particular element of an array would require, like if I would like to delete this array, this particular point, then I would be able to reach this point in order of one time, because array is index based. And afterwards, if you would like to delete this particular location, so we could not delete it, because array size we cannot mutate. So it's immutable. So basically, to delete this point, we'll have to shift every element that are after this index to this particular position, the I plus one to ith position. Let's say if it is on ith position, then I have to shift this I plus one to ith, I plus two to I1, I plus one. Similarly, and the element at the last node, that is n minus 1 to n minus 2, I have to shift. And afterwards, this position would contain a null value. There will be no valid value to that particular position. But in linked list, we could have a simply we could simply relink whatever the current existing link we have. Let's say if I would like to delete this particular value on this position, then I would simply delete this node by relinking the existing node linkage. So if I could somehow get the link of this previous node updated to the next node, then simply this link would be broken, and we will be left with this particular node, and we can always go ahead and free this space from the memory. So that are the few advantages of having a linked list. Also, if I would like to add an element to particular ith position, then I'll have to if I would like to have some value added to this particular position, then let's say I've added some value to this particular position, then afterwards, before updating this value, you have to shift each element from this position onwards to the next plus one position. But in case of linked list, we could simply, if I would like to add some value, we could have a node, and we could again work on relinking the particular node to that position. let's say like if I delete this link and update it like this one, then simply in order of one time we'll be able to add a new node to this existing like linked list. Yeah, like the complexity would be like we would also have to consider the complexity of traversing tail here, which need not to be done in case of array. But again, if I'm having the access to the particular node where I would like to update the add the value of just after it, then we could simply do it by like relinking. So that would also take an order of one. So we need not to traverse to that particular node. These are the advantages of these are some of the advantages of linked list. And linked lists are generally used in longer stream of data where the like data is keep on coming. There is no end to it. So in those cases, like array would fail because array needs to be declared with a fixed size, but that is not the case with linked list, right? So starting with like what are the requirements of having a linked list is like we like for sure we need a node is like a kind of data like a user defined data which contains some information that requires to the user. Let's say it is a kind of int data which contains the ID of particular product. Let's say this node represents a product and this ID represents the like ID number of that product registered in the database. There is a link. We need a link. So this is a single linked list. So all of the links are like pointing to the next node. So in that case, like we only require a single link that is to the next node, right? And similarly, we can go ahead and like create a number of nodes. So if I would like to add a new node to existing linked list, we could simply traverse to the last node and like append a node by linking the next node to that particular node. So let's say I have created a new node with some int ID value, and its link next is pointing to null right now, right? And I need to append it to the last to the end of this node. In that case, I could simply like point this next to next of the last node of linked list to the existing node of like to the new node which we have just created, right? So this is like adding a node to end of single linked list, right? And let's say if I would like to add a node to the start of the linked list, so instead of end, I would like to add somewhere at the start of the linked list. So if I'm having a linked list already existing, and if I would like to add a node to start of it, so how would we identify if where our linked list is starting? So there is a pointer called head that is pointing to the start of the linked list. Will be provided with this head, and now we need to add a new node to start of it, which would be pointing to the next node. That is like this particular node would be pointing to the head, and will update this head to this particular position. So simply like if we are having a node, let's say, and we have created a new node with some value, and now I would like to like point the next of this particular node to head. Like in that cases, p of next would contain the head would be pointing at that point to this particular like the previous head of the linked list. and now P is pointing to this linkage has been created now. That is the step. Like step 1 is like creation of this node. Step 2 is like linking this particular next of the new node to head, and afterwards like updating the head value to current new node. So this linkage will be broken, and a new link will be created where head will be pointing to the new head of the linked list. So in this way we'll be able to like add a new node to the start of the linked list. And now the third case arises where we would like to add a new node in anywhere in between of the linked list. So like let's say in the like anywhere in between. Okay, so let's say I have a node which I have created, which is whose next is currently pointing to null value, and null, and some data value val is being stored in the new node. I would like to link it after this particular P node, and in these cases like I could relink this thing. So let's say P is currently this one. So next of P would be like this. So let's say and head would be pointing to this. And let's say this is the next of P. This is next of P, and P is pointing to this. Now I would like next of P to point to this node, and this node's next to point to next of P, right? So first I would like to link next of this particular new node to next of P. In this way the next of this node would be pointing to this. Afterwards like I would like to delete this link and update it to this node. In this way this node, like this linkage would be broken, and our P node would be pointing to this, and this would be pointing, new node would be pointing to the next. So in this case we would be able to add this node in between like P and next of P. Let's say instead of calling it next of P, we could rename it as Q. So in between P and Q we have updated a new node. How would we be able to implement it? That would be like we could first we need to create a new node. Let's say new node we have created, and afterwards new node would be new node, next of new node would point to Q, and next of P would point to new node. In this way our linkage would be set up. How would we determine Q? Q is simply next of P before we have relinked any of the node. So in this way we would be able to append this a node in between P and Q. So I believe that's all for singly linked list. There are majorly three operations, that is append a node at the end of the linked list, append a node at the start of the linked list, append the node anywhere in between the linked list, between any two nodes of the linked list, obviously. So these three approaches I have already explained. Why we require a single linked list, I already have covered. And singly linked lists are majorly built of nodes connected via links. So to give you how would you create a node? So let's say you have a class named node, and the value we can store as a character, string, or a numerous number of values we can store for a node. For now I am just storing it have a int with the variable val, and I need a link that points to the next of it. So that link also like contains the address or the information about the next node. So that the type of that would be node only, and that would be like next. We could like go ahead making it public so that we would be able to access the next node outside of the class as well. And like we could go ahead creating the constructor would take the value and create a new node. So this dot val would contain a val, and next of it, this dot next would contain a null. Since we are not providing any link to this link to new node while creating it, right? So in this way, you could go ahead and create a single linked list and perform these three operations. We'll be going ahead with further topics in next lecture. Thank you very much for watching this video.